Alright, in today's discussion we are going to talk about matrix multiplication. And there's a couple things we need to start off by talking about. First is that matrices, we can say if we have matrices A and B, they can be multiplied if and only if the number of columns in A equals the number of rows in B. Also, we say if matrix A has dimensions m by n, m columns by n rows, correction, m rows and n columns, and matrix B has dimensions n by p, n rows and p columns, then the resulting dimensions of AB, matrix A times B, is m rows by p columns. Now before we get into our first example, I'm going to put 5 matrices up on the screen. If you're taking notes in your notebook, make sure you copy these down. So first we're going to have matrix A, which has 4 rows and 3 columns. So we've got -6, 2, 8, 0, -1, 5, 16, 4, -10, and -3, 13, -7. Matrix B is going to be a simple row matrix. -11, 4, 19, -2, and 6. C will have 2 rows, 4 columns. We're going to have 0, 1, -6, 19, 14, 9, -5, -2. D is going to be just a simple column matrix with 3 elements. We're going to have 8, 7, and -1. And then E is going to be 2 columns and 5 rows. So 5 rows, it's a 5 by 2. We're going to have 5, -2, -13, 11, 26, -9, 3, and 17, -1. So our first example, our first set of examples, has us using the given matrices, which I just gave you, determine if the product is defined, if we can multiply them, and if yes, then we're going to give the dimensions of the resulting product. That's all we're going to do. That's it. So first I'm going to write down the products, and then we're going to determine if we can or can't find the product. Alright, so first we've got AD. Let's write the dimensions of matrix A. We know it has 4 rows and 3 columns. So that means A is a 4 by 3 matrix. D, when we look at that, it is just a column matrix, which means it's got 3 rows, 1 column. It's a 3 by 1. If we're going off the criteria of what we had in our previous slides, the only way we can do this is if the number of columns in the first matrix is equal to the number of rows in the second. So if this second number from the first matrix is the same as the first number from the second. We've got that, so yes, we can find a product. The new dimensions are going to be the number of columns, or I mean the number of rows from the first matrix, 4, by the number of columns in the second. So it's going to be a 4 by 1 matrix. AC. So A, we know that's a 4 by 3 matrix. C, when we look at that, we've got 2 rows, 4 columns. That means it's a 2 by 4 matrix. The number of columns in A does not match up with the number of rows in C, so we cannot find that product. In BE, B is just a simple row matrix. It's got 1 row by 5 columns. E is a 5-row matrix with 2 columns, so it's a 5 by 2. Since the number of columns in B is equal to the number of rows in E, we can multiply them, and the resulting matrix is going to have the dimensions 1 row, 2 columns. In fact, 1 row, 2 columns. Now we've got a BD. We know B is 1 by 5. And we know D is 3 by 1. The number of columns in B does not match with the number of rows in D, so this one cannot be multiplied. CA, C we know is 2 by 4. A we know is 4 by 3. Since the number of columns in C matches with the number of rows in A, we can certainly multiply them, and the resulting dimensions are going to be 2 by 3. EC. E we know is 5 by 2. C is 2 by 4. Since the number of columns in E matches the number of rows in C, we can multiply them. The resulting matrix is going to be a 5 by 4 matrix. EC will be 5 by 4. EB, E we know is 5 by 2, and B we know is 1 by 5. Since the number of columns does not equal the number of rows in the 2 different matrices, then we say that this cannot happen. And then DB. D we know is a 3 by 1 matrix. B is a 1 by 5 matrix. Since the number of columns in D matches the number of rows in B, we can multiply and get DB. And the dimensions of DB will be 3 by 5. So now the question is, how do you multiply matrices? Well, what we do is we say the element in the mth row of and nth column of matrix AB is the sum of the products of the corresponding elements in row M of matrix A and column N of matrix B. Shown by the following pattern. So we can say if A is a square matrix, we'll say we've got A, B, C, D. And B, we'll say, is also a square matrix, just for ease. We'll call those elements E, F, G, and H. Then what we can say is the matrix A times B is going to be equal to, it's going to be a square matrix again. We're going to go A times E plus B times G to get that first element in that first row. And the second element in that first row is going to be A times F plus B times H. And now we can move into the second row. The second row is going to be row 2, column 1 will be CE plus DG. And then the second row, second column will be CF plus DH. So let's look at some examples. We're just going to find the product. So example 9, we're going to multiply the matrix -4, -9, 3, -2 by the matrix 6, -1, -5, 4. They're both 2 by 2 matrices. They're both square matrices. So then the resulting product is going to be, we're going to go -4 times 6 plus -9 times -5 for that first element, and then the second element is going to be -4 times -1 plus 3, -9 times 4. And then we move on to the second row. We're going to have 3 times 6 plus -2 times -5. And then the second row, second element is going to be 3 times -1 plus -2 times 4. And then we can do the multiplying and adding. So let's start with the multiplying. We're going to have -4 times 6 is -24. -9 times 5 is going to give us 45, so -24 plus 45. -4 times -1 is +4. Minus -9 times 4 makes 36. 3 times 6 is 18. Plus 10. And 3 minus 8. Which means now if we do the addition and subtraction, our final product, our final answer is going to be the matrix 21, -32, 28. And I did make a mistake in my previous part of work. 3 times -1 is not 3. It's -3, which is going to give me -11 in that last element. So If I take the two matrices and multiply them, we get 21, negative 32, 28, negative 11. Let's look at another example. Example 10. We're going to multiply negative 2, 0, 6, 4 by 8, negative 3, and negative 2, negative 9. So we're going to go negative 2 times 8 plus 0 times negative 2, and then we're going to go negative 2 times negative 3 plus 0 times negative 9, then we're going to go 6 times 8 plus 4 times negative 2, and then 6 times negative 3 plus 4 times negative 9. If we do the multiplication, our next line of work is going to look like negative 16 plus 0, and then 6 plus 0. Then we're going to get 48 minus 8. We're going to get 18, negative 18, minus 36. So now we can do the addition, and our final answer is going to be the matrix negative 16, 6, 40, negative 54. I think we have time to squeeze, for sure, one more example into this video. We'll try to do more. Example 11, we're going to have the matrix negative 7, 2, negative 11, 3, negative 5, negative 2. We're going to multiply that by negative 6, 4, negative 3. So before, we just looked at multiplying two square matrices. In this example, we don't have that. So we have a 2 by 3 matrix and a 3 by 1 matrix. We do know we can still multiply it since the number of columns in the first matrix is equal to the number of rows in the second. So let's start by writing out what we're going to have here. We're going to take negative 7 times negative 6, then add to that 2 times 4, and add to that negative 11 times negative 3, and in our next row, because we know we're going to have a 2 by 1 matrix here, we're going to go 3 times negative 6 plus negative 5 times 4 plus negative 2 times negative 3. Now let's take care of the multiplication. So if we take care of the multiplication, we're going to end up with 42 plus 8 plus 33 in the first row, and then we're going to end up with negative 18 minus 20 plus 6 in the second row. Now we can actually do the addition. In our first row, we're going to have 88, we're going to have 83. And in the second row, we're going to have negative 32. And that's going to actually wrap up this first video on multiplying matrices.